Hello everyone, and thank you very much for joining us. My name is Gleb, and I'm working as a delivery manager at OntargIT. We are continuing our series about Microsoft Cloud for Manufacturing. Today, we are going to discuss how Microsoft Dynamics 365 may help you enhance factory performance and make step ahead towards connected factory. If we look at typical automation stack, when companies have successfully implemented ERP application, they are planning to adopt warehouse management or manufacturing execution system. On the left-hand side, we see the common approach when those systems are purchased and implemented separately. Sometimes, even though the systems from the same vendor, their data models are different and integrations run periodically to share the data. But it doesn't allow managers to have just-in-time visibility. Plus, it costs a lot of money, not only in terms of licensing, but also in terms of integration development and system support in the long run. In order to address this issue, Microsoft, in collaboration with industry professionals, has designed best-in-class for manufacturing execution and warehouse management within its core ERP offering, which is called Dynamics 365 for supply chain management. As we can see on the right-hand side, there are some open interfaces available if we need to integrate, for example, with material handling equipment or production asset sensors. Okay, you might say, we already have an ERP from a whatever vendor. It tracks my production process and calculate costs, inventory, and resources. Why do we need to invest in these subsystems? Whether adoption of them really matters? Well, the answer is yes, and will definitely increase your IT maturity level and provide the following benefits. And I will just outline the basic ones. For the warehouse management perspective, system allows you to break down inventory to the batch, location, and pallet level. Every material movement is tracked by a worker via mobile app. Because of that, inventory accuracy is improved. Customers who have already implemented WMS reports that deviations after inventory counting is dramatically decreased, reducing the cost of lost items. Second, the system directs the worker where to pick from and where to put the goods to. It reduces unnecessary turnarounds and optimizes picking routes, which generally leads to reduced labor costs and increased fulfillment rates of on-time and in-full deliveries. And because we get digital representation of your warehouse layout, like location capacities and storage policies, you can optimize storage space utilization by adoption of consolidated strategies when system guides workers to store similar products close to each other. Okay, and in terms of manufacturing execution, I'd like to emphasize that the core benefit is increase of overall equipment effectiveness, which most manufacturers are keen on. The ability for a worker to easily track each job assigned to him in terms of time clocking, asset downtime incidents, and waste produced generates a layer of meaningful data that management in most cases don't see. The real problem in data capturing is not about huge downtime events. Productivity opportunities are hidden in the real time, these micro stops. You can capture them by leveraging manufacturing execution system. Traditionally, enterprises were focusing on big issues only because it was too expensive to focus on anything else. These micro stops potentially can overweight all the major downtimes. In addition to that, is elimination of paper operations, because all jobs are going to be reported digitally on a touch screen. For chemicals, pharmaceutical, food and beverage manufacturers, where traceability back to raw material vendor is important, it allows to seamlessly record raw material batches for each operation. We will see later on our demo that you can add digital instructions to workers for every operation, which accelerates time to value for new workers and increased safety. By this slide, I just would like to remind you that the capabilities we are going to see today are made available within Microsoft Cloud ecosystem. I just have made a snapshot of product modules that enables digital feedback loop. For example, when you start production order, you also need to account for finished good costs and work in processes, register downtime and asset maintenance requests, send the time and attendance information to HR system for payroll, run master planning to understand materials and resource requirements, and so on. All of these applications within Dynamics 365 have a common data model and closely integrated. And finally, all is data available on Azure Data Lake for Power BI analytics. Dynamics 365 provides flexible feature enablement and licensing, so your cloud solution can grow as your business grows, while all basic industry needs are available out of the box. If we go back to a factory execution, to enable workers to capture and view data on the go, an IT infrastructure should provide them with lightweight mobile applications. These applications should be supported on various platforms and industry-tailored devices with a touchscreen experience. Companies want to have a centralized management of user experience, as different workers have different needs to perform operations on the workstations. Microsoft had developed Warehouse app and production shop floor interface to meet those requirements. Warehouse application on the left-hand side is supported on Android and Windows devices with infrared scanners like Zebra. User interface is scalable depending on the screen size and optimized for mobile usage. Production shop floor interface on the right-hand side is a web application available within Dynamics 365 via any modern browser and optimized for touchscreens. Before we move on to a demo, I'd like to note the two core engines of warehouse and manufacturing workloads. Location directives engine is built to automatically determine warehouse location for material pick and put operations. It considers company policies as well as many other parameters like raw material characteristics, location capacity, warehouse blueprint, available inventory, etc. It optimizes warehouse work execution by guiding the path to the desired products. And the second one is a job scheduling engine. It's designed to help production planners and supervisors to allocate resources to production requirements. It takes into account multiple parameters like resource availability and capacity, skills need to perform a job, production route, and many more. This engine works together with Microsoft Planning to schedule production not only within a day, but also to evaluate mid-term and long-term production plans. I have opened all production orders form in Dynamics 365 Supply Chain Management. A new order has been created, a finished product, which is 2 liters of plastic bottled beer. The total production requirement is 22 pallets. Formula shows that in order to produce 1 pallet of bottled beer, we need 672 liters of beer and 336 bottles and bottle caps. These quantities are shown in pieces. And actually we need 1 pallet as a packaging material. So before we can start an order, we need to bring this wooden pallet to a palletizer. First, I will estimate an order to get quantity and cost calculations for 22 pallets. The second step is schedule the job. This step is typically performed by production planner or automatically generated by master planning engine. In this demo scenario, the standard production time for 22 pallets is set to 1 hour. If I open the Gantt chart, we can see that system plans an order to a next available hour because production line has already been reserved for another orders. This form helps production planner see the job plan for a day. You can also manually reschedule it by dragging and dropping production job to another slot or assigning it to another resource. When production order is scheduled, we can release it. When order is released, system will generate warehouse work to bring wooden pallet to a production line and make manufacturing job available for production floor execution. When I open warehouse work details, we see that system generated a new warehouse work to bring in 22 wooden pallets from raw material storage to a palletizer input location. I will use Warehouse app to execute this work. So the worker logs into app using his personal login and password. Now he can see a list of available operations. The list can be configured for any type of worker and warehouse task to perform. By clicking raw material picking, I have configured the system so that it suggests the next work to execute. We can see what item is required and where to pick it from. System asks to scan license plate ID in case we divided location space further in that location. It's an optional step. When pallets are picked, system directs the worker to a palletizer input location when they are consumed. When worker moved items to a destination, it indicates the job is completed. If we switch back to Dynamics 365, we can see that system has registered the movement between locations. Okay, now I switch over to production flow execution interface to start production job. On the first screen, an operator needs to scan his badge ID to start. There is also an option to lock and sanitize the screen. As soon as worker log in, system registers time clock to track time spent by a worker on a shift. This production screen execution interface is configured to show all production jobs assigned to a bottling production line resource group. I will select the last order to start. By default, the started quantity equal to production order quantity. When production materials The last topic I would like to show you today is one of the recent updates in Dynamics 365 portfolio. It's distributed topology for manufacturing execution and warehouse management workloads. When we look at factory and warehouse operations, we can divide them in two categories. A back office, where we schedule production jobs and register orders that need to be fulfilled, and the front office, inside the factory or physical warehouse, where we execute the jobs assigned. When the whole system is deployed in the cloud in a particular Asia region, but real warehouses and factories located in different parts of the world, it may lead to poor system performance due to big latency and sometimes complete stop of operation if internet connectivity is lost. In order to enable business continuity in case of disruption, there is an option to deploy a separate system unit on a local servers inside facility, which is called edge scale unit, or in the cloud in a different Asia region as close as possible to operations, which is called cloud scale unit. If internet connectivity to a hub or back office system is lost, business may continue its operations. Data will be synchronized back later when a connectivity to a hub is fixed. It gives business an opportunity to have a hybrid deployment that minimizes downtimes due to internet connectivity issues. So several deployment options are available for customers. The basic full cloud deployment, hub and cloud scale unit to increase system throughput and performance, hub and edge scale unit as a dedicated on-premise deployment unit, which work autonomously when internet connectivity is lost, and full on-premise deployment. Deployment topology may be changed over time in accordance to business need. You can mix and match scale units, and system administrator can activate and deactivate necessary scale units. The supported workloads are mentioned on the slide, and Microsoft is working to expand scale unit capabilities down the road. All right. Thank you very much for your attention. Please feel free to ask any question. We will be glad to support you. And I hope to see you our next webinar on Tuesday. Bye.